Sharing with you an important probability distribution function. I am Anil Kumar. Welcome to your YouTube channel, a platform where we share our thoughts and learn continuously. Here is another brilliant question from our IBHL student. The probability density function of a continuous random variable x is given by f of x equals to k over x squared plus 4, where k belongs to the closed interval of 0 to 2. Part A is find the value of k. Part B, show that the function f is decreasing in the domain 0 to 2. C is find expected value in the form ln a over pi. Perfect. You can always pause the video, answer the question. So when we are given probability density function, then how can we find the value of k? Well, clearly the area under this continuous random variable x should be equal to 1. So that is the basic concept. So we'll begin by finding the integral for the given function f of x, right? And the function given to us is k over x squared plus 4 from 0 to 2, right? And this should be equal to 1. Straightforward, so that should help you to get the value of k. Only difficulty could be that if you don't remember the formula, then how do you integrate, right? So let me give you the formula right there on the top, so that normally in IB test papers, the formulas are given to you. So if you have something like 1 over, in this case we have a constant, a square plus x square dx, then the integral is 1 over a arctan of, or tan inverse, right, x over a. Of course, plus c, but now we are working in definite integrals, so we'll find the value. So that is the beginning, right? So I hope this is clear. So let's begin with the solution of part A on a fresh page, right? So we are given the function f of x, which is k over x squared plus 4. So as I said, since we want to find the value of k, and this is probability density function, and it's a continuous random variable given to us, then the integral should be 1. So the area under the curve, right? So f of x of this function, let me write 4 as 2 square, makes sense, right? Is given from 0 to 2 dx. That's what we want to find, right? And this should be equal to 1. So that should help us to find the answer. As we just saw, the formula for this, right? So we can write this as 1 over. Now k is a constant. So I can take k outside over 2. And then we have tan inverse arctan. We can write arctan x over 2 from 0 to 2. Make sense? So that is how we are going to get the value of k. So we get 1 equals to k over 2. And here we have arctan. 2 by 2 is 1 minus arctan 0. So 1 equals to k by 2 times, this is pi by 4, right, minus 0. So 1 equals to k pi by 8. Cross multiply to get the value of k, which is 8 by pi. So we get the value of k as 8 by pi. So that is how we will find the value of k. Now, since we are going to use this formula in coming parts of this question, let me rewrite the formula once again. So we just found that f of x is equal to 8 by pi times 1 over x square plus 4, and the interval being 0 to 2. Is that clear to you, right? So I hope this part is absolutely clear. Let's move on to the next part of the question. So k is 8 by pi. Part B of this question is to show that the function f is decreasing in the domain, right? So we just found the function f of x as k is 8 by pi and rest of the function is 1 over x square plus 4, right? Interval 0 to 2. Perfect. So now we need to show that the function is decreasing in the closed interval 0 to 2. How will you do that part? Well, if the function is decreasing, we need to find the first derivative, right? And decreasing means it has to be less than 0, negative. So if the derivative is negative, then the function is decreasing. Perfect. So with that concept, let's move forward. So we have the function now, f of x equals to the constant 8 over pi times rational function x square plus 4. Right. Now, let's find the derivative of this function. So the derivative will be what? Constant 8 over pi, right? We can apply the quotient rule. So let me write the dx of 1 over x square plus 4. Right. So which is, let me write here. So the derivative of this function is 8 by pi. And we are going to apply the quotient rule on this. Denominator square. Now 1 derivative is 0, 0 minus 1 time derivative of x square plus 4, which is 2x. Open the bracket, so we get minus 16x over pi times x square plus 4 whole square, right? Now this is within the interval 0 to 2. So as you can see here, since the interval is from 0 to 2, x values are positive, right? So definitely this is less than 0. So we have shown that the derivative of the function is less than 0, and that implies that the function f is decreasing. Right, in the domain 0 to 2. Is that clear to you? Right. So it is non-negative, therefore it is decreasing in the domain 0 to 2. Perfect. So that is how we are going to do part B. Now let's move on to part C of this question, which is the probability density function of a continuous random variable is given to you. We just found k as 8 by pi. We need to find the expected value Ex or in the form ln x over pi. So how do you find the expected value? So expected value is given by the formula integral from minus infinity to plus infinity of x times f of x dx, correct? So that is the expected value. So now if you integrate this, then you can get the expected value, right? So let's do that part. So expected value is from minus infinity to infinity x times 8 over pi, which is the k value, times 1 over x square plus 4 dx. So I've kind of split it apart so that it's easier for us to visualize. So this is the integral which we want to find. And we have to write the answer in terms of log function, base e, ln. So that gives you a hint actually. And the hint is very clear that we can do a substitution, which is let u equals to x squared plus 4. And therefore, that will give you du equals to 2x dx, correct? So that becomes the substitution for this integral. And now we can find the expected value. So expected value. Now we are given this interval is from 0 to 2. Correct? So basically, we are going to integrate between 0 to 2, right? However, there is a catch here, that is, since you change the variable to u, we have to also find what are the new limits for u, right? So if x is 0, let me write here x equals to 0. In that case, u equals to what? U equals to 4, right? Because 0 square plus 4. And if x equals to 2, then u equals to what? 2 square is 4. 4 plus 4 is 8. So your limit changes from 4 to 8, right? So we'll write this limit from 4 to 8. Correct. And replace x dx with du, but it is 2 times. So we'll split 8 into 4 times 2, right? Correct. So what I will do here is I'll do it in 2 steps, right? So let me first write the function in x itself. So we are writing this as from 0 to 2, and 8x I'm writing as 4 times 2x, right? Dx. Is that clear to you? And here I'm writing x square plus 4. So that will make it absolutely clear. Correct? So 0, when you substitute for u, it becomes 4. So the integral, change the ink. So integral becomes from 4 to 8. Constant 4 remains, right? 2x dx becomes du. And we have x square plus 4 in the denominator as u. Is that clear to you? Pi is also there. I forgot to write pi here. So u and 4 and pi is also there, right? 4 by pi. Now the integral for this is 4 by pi, right? ln u from 4 to 8. Makes sense, right? So that is how we are going to write down the integral now. The constant 4 over pi can be taken out, and integral of 1 over u du in the interval 4 to 8. Correct. So that expected value now is 4 over pi, and we have here ln. If I put 8 here, minus ln 4. Correct? So that means you can divide them. So it is 4 over pi ln 8 over 4, which is 4 over pi ln2. Is that clear to you? So 4 over pi ln2. However, you need the solution ln a over pi, right? So that means I could write, and pi is there in the denominator, that's not an issue. So 4 can be exponent of 2, right? So we could write this as equal to, let me write in red now. 4 I'm taking here, so I'm writing ln 2 to the power of 4, right? Over pi. Is that clear to you? So that becomes our expected value. And now we can write, correct? So let me use this space. So we got the expected value Ex as equal to 4. We took inside ln 2 to the power of 4 is 16 over pi. And that gives you the answer that A is equal to 16. Is that clear to you? So that is how we are going to answer this particular question. So I hope the concept is absolutely clear. So with that, we solve all the three parts of this problem. I hope it makes sense. The idea was here the integral of f of x in the given domain of 0 to 2 should be equal to 1. Here the idea was to find the derivative and show it less than 0. Here it was expected value, as you know, is integral of x times f of x, correct? Within the interval. We did substitution of variable to find our answer. And we found that a was equals to 16. Perfect. So that is how we have to solve this particular question. Very interesting, beautiful problem. I hope the sequence through which we've gone through will help you to master statistics, expected value part in greater details. Feel free to write your comments, share your views. If you like and subscribe to my videos, that'd be great. And keep sharing, keep posting problems. We'll provide you with brilliant solutions. Thank you.